Hi, welcome to my channel. Today we'll be doing a short derivation of arc length. What I have drawn here is a circle of radius r and center point C, and we have two rays that extend from center point C and intersect the outer circle at points A and B. The angle between the two rays is what I'm calling theta sub d. And this angle is often referred to as the center angle because the vertex lies at the center of the circle. It can also be referred to as angular displacement or angular distance. They all mean the same thing. It really depends upon your text. Now, this portion of the outer circle that lies between A and B is referred to as arc. So, and specifically, it's the arc AB is what this is called. I'm going to go ahead and draw that here. This is called arc AB, and the distance or the length between points A and B, the endpoints of this arc, is known as the arc length, and that's actually what we're trying to figure out today. So essentially what we want is we want a mathematical equation that describes the relationship between all the parameters that we've discussed so far so that we can solve for length L, for the arc length. Okay, well, let's get to it. Okay, so what do we know about this circle? What else do we know? Not just this circle, but any circle. We know that its total length, in other words, the total distance around this outer perimeter, the circular path, the total distance of the circular path all the way around is known as the circumference, and it is 2 pi times the radius r. So I'm going to go ahead and write that, down. All right, and we know something else. We know that the total angle around the circle is 360 degrees. So this is 360 degrees. That means that if you start at any point and you keep going along the circular path, once you get to, if you keep rotating 360 degrees, you're going to get back to exactly where you started from. So the total angle of a circle is 360 degrees. So that's the number of degrees for one revolution. Okay, so what do we have here? What we have here is we have the total length, the circumference, and we have the total angle. What we have here with the central angle and the arc length are the partial angles and the partial lengths. And there is a relationship here. It turns out that the relationship between the center angle to the total angle is actually the same relationship as the arc length is to the circumference. So let's go ahead and write that out mathematically. So we have L over 2 pi r equals theta sub d over 360 degrees. Now let's simplify to get L by itself. So we want to multiply this side by 2 pi r because we want to get rid of this. Now if we multiply the left side by 2 pi r, we have to multiply the right side by 2 pi r to maintain our equality. So what we end up getting is L equals theta sub d divided by 360 degrees times 2 pi r. And there you go. That's our relationship. Okay, well, hopefully this makes intuitive sense at this point. What we have is arc length is equal to the circumference multiplied by this component. So this component defines the relationship of the central angle to 360 degrees. So the arc length is simply the circumference multiplied by the fraction of the total angle that the central angle occupies. Now we can simplify this a little bit further. Oops, I didn't mean to cross out that. Divide both the numerator and the denominator by 2, and we should get the central angle divided by 180 degrees times pi r. And there you go. That's our final answer. That's our equation. Okay, well, I hope you guys found that helpful. If you did, please leave a like and subscribe, and I'll be back shortly with another video.